Hello. So in this experiment, we are going to discuss about the determination of Planck constant by using the photocell. Planck in 1900, he discovered one concept. That concept is quantum concept. So what is the quantum? A energy packet, we call it as a quantum. At the radiation of energy packet, we call it as a quantum. So what is that radiation? That radiation, we call it as a radiation. That radiation packet, it light will come as a packets. Each and every packet has the energy. That energy, we call it as a quanta. Clear? So that constant, he gave one formula, that is the discrete energy formula. E is equal to h nu. Here h is a Planck constant. That constant value we have to calculate by using the photocell experiment. What we have to do? So here we need to take one great adjustment we are taking. First, you able to write it as a whatever the vi characteristics curve we did, that reverse you have to do. That is one thing you have to take it as. So that reversely you have to do it. So wherever the normal, you have to keep it as a sensitive. Wherever the 50, you have to keep it as a 1, you have to keep. So 1, you able to keep it. Is clear? Now you fix that. So for fixed distance, you have to keep it is. So this is the, you able to keep that light intensity, you have to keep it the fixed distance I am keeping. Now what we have to do? So here that principle is h nu is equal to 1 by mv square plus h nu naught. H minus h nu naught is equal to 1 by mv square is equal to ev, that is the energy. This potential we call it as a stopping potential. What is the stopping potential? Whenever the applying the stopping potential, in that time current is going to become as a zero. So that zero current we need to calculate. How much potential we have to do? For what we have to do? For we are going for that, we able to take the observations. For each and every color, for violet color 404050 angstrom, that is the fixed wavelength. For a blue color 4360 fixed wavelength. For a green color 45460 fixed wavelength. For a yellow color 5780 fixed wavelength. For red color 6910 fixed angstrom is there. Now, so you know that mu is equal to c by lambda. C is equal to 3 into 10 to the power of 8 meter per second. So in terms of centimeters are there, that's why you have to take 3 into 10 to the power of 10 meter per second. This is the velocity of the light. Now you substituted here for blue color, you have to substituted c is divided by lambda of blue. You have to substitute, you able to get it as a blue color frequency. These are the fixed frequencies for different colors. What we have to do? First, which one you able to take? Red you have to take. So already red is there. Red, I am keeping the red. Clear? Red filter I am keeping. I am incidenting the light. So now what we have to do? Whatever the voltage you have to increase. Now automatically your current is decreasing now. Whenever the current is zero, so whenever the current is zero, that current you have to take. So that current you have to take. So now you have to go it is for 1, you are completely shut out. So that is up to that one only there. So again it is not going, that indicator is shut out. For what? For 80 volts, the stopping potential you need to calculate. Now otherwise you have to minimize this. So what will happen? You have to see, you minimize, you able to get it. That is the shutdown only coming. Now you take yellow. So red you remove, yellow you have to take. For yellow you also you keep this. So you increasing this, right? Now wherever, whichever voltage that current is zero, that current you have to measure. Now this is now it is going to take it as a 8.5, that is completely going to zero. So 8.5 you have to write, it is yellow only, no? 8.5. so 8.5, 0.85, this 0.85, 0.8, because this upside you have to take. For 1 volt to apply, no? 0, 0.2, 0.4, 0.8, 0.6, 0.8, 1 is there, right? So like that you have to do. So not only that, green you able to take, green you have to take. So that green you have to keep. Again you increase that. So you changing now. So you changing. Whenever this is going to be shut off, so that one you have to take. Up to that only is meter is going to there. So that one you have to keep. So that is the 0.89 is coming. 0.89 for green. 0.89 and so on. Different colors for different filters you have to keep. Adjust the voltage whenever this indicator is falling down up to the zero. That reading you have to take, that is the stopping potential. Now you have to take the graph. So that graph will come. So according to this, your formula is equal to H. So this formula is there. H nu is divided by E. H nu is divided by E minus H nu naught is divided by E. Y is equal to mx plus c. Here c is the intercept, y intercept. So now your curve is going to get it. This is the y intercept. That y intercept is h nu naught by e, it will come. Clear? This is the intercept. Through the slope it will come. That slope will give, so delta v naught by delta nu. Delta v naught by delta nu. So which one it will give? So that will give the, you have to take it as a 1 by e value are going to give it. So that h by e value are going to give that slope. M is equal to, you have to write it as h by e. H by E is equal to slope. So therefore H is a Planck constant. Slope into E you have to write. What is the E? E is the charge of the electron. That electron value is 1.6 into 10 to the power of minus 19 coulombs. So the slope you have to find this curve. So that slope may be you multiplied with slope. So then how much you are going to get it? H value you are going to get. That value is 6.626 into 10 to the power of minus 34 joule second. This is the universal constant. Wherever you go, whichever country you have to calculate that Planck constant, the same value are going to get it. So like this we able to calculate the Planck constant using the photocell experiment. Clear? So only one thing you have to do, you able to reverse it while you are doing the VI characteristics inverse square law you apply now. So based on that you have to reverse it, the circuit will happen. Clear? So like this you have to do. Please share, subscribe and like our YouTube channel. Thank you.